Lesson 4.7, the real number system. We're going to identify and compare numbers in the real number system, and we're going to solve equations by finding square roots or cube roots. The Common Core state standards are listed in the mathematical practices. So here is a visual of the real number system. We have our rational numbers that we learned earlier this year and our irrational numbers that are included in the real number system. So the real number system breaks down to rational numbers and irrational numbers. So you've seen this visual earlier this year. Your natural numbers are your 1, 2, 3, 4, 5, 6, 7, and so on. Those are your counting numbers. Then we add in 0. So 0, 1, 2, 3, 4, and so on is your whole numbers. Then the set gets bigger. It's now the set of integers. It adds in those whole numbers and their opposites. And then your rational numbers are any number that can be written as a fraction. Now you're being introduced to irrational numbers, and those are numbers that cannot be written as a fraction. Those would be non-perfect squares, pi, repeating decimals that don't have a set pattern that never end. So this is your real number system. So here's a little diagram of the real number system. So all these numbers we're looking at are your real numbers. They break down into two parts, your rational numbers and your irrational numbers. If it's a number that cannot be written as a fraction, that's your set of irrational numbers. If it is a number that can be written as a fraction, that falls into your rational numbers. It also can break down to a smaller set. If there's no fraction forms, it's just positive and negative numbers, whole numbers and their opposite, falls into your set of integers. Our set gets smaller if we take out all our negative numbers. So if we have 0, 1, 2, 3, 4, 5, and so on, that's your set of whole numbers. We take away 0, we get our natural numbers, 1, 2, 3, 4, 5, and so on. So we are going to classify each of these numbers. We are going to use the chart below. The directions say, name the set of numbers to which real numbers belong. Let n be your natural numbers, w be your whole numbers, z integers, q rational numbers, I irrational numbers. Be sure to check all that applies. So we have 0. 0 is a whole number. It doesn't fall into your set of natural numbers because that starts at 1. It falls into the set of integers. It's also a rational number, and it's also real. Number 4. Number 4, you first see it in your set of natural numbers. That's your counting numbers. It also falls into your set of whole numbers, your integers. It's a rational number, so it is a real number. -7 will not fall into a set of whole or natural because it's negative. So it first appears in your set of integers. It's also a rational number, and it falls into real. 1/4 is a fraction. That does not appear in the set of natural numbers, whole numbers, or integers. So it first appears in your set of rational. It's also real. 2.7, repeating, does not fall into natural whole integer because we've got a repeating decimal. So it first appears in your rational set, and it's also real. Since 2.7 is a repeating decimal, we can write it as a mixed number, which is 2 7/9, and we can convert that into an improper fraction. The next one, 0.1121231234 ... is a repeating decimal that has no set pattern. That is irrational. We cannot turn it into a fraction. It also falls in the set of real numbers. 4/2 can be simplified down to 2. So 2 falls into natural, whole, integer, rational, and also real. -1.5, even though it has a negative in front of it, it is a rational number, and it's also real. Pi is an example of an irrational number, and it's also real. 3 3/8 is an example of a rational number, and it's also real. Comparing real numbers. Express each number as a decimal, then compare decimals. Square roots. If an integer is not a perfect square, then its square root is an irrational number. So replace each blank with less than, greater than, or equal. So we have 2 2/5. The first thing that we want to do is convert that to a decimal. You can use a calculator, or you might have this already memorized. So the square root of 61, using a calculator, is about 7.8. We only need to go to the 10th spot because that's where they're different. So the 4 is smaller than the 8, so 2 2/5 is less than the square root of 61. Number 2, 3 1/3, is that greater than, less than, or equal to the square root of 15? Well, the square root, 1/3 written as a fraction is 3.33 repeating. The square root of 15, using your calculator, is about 3.87. So our 3's are the same, but they're different in the tenth spot. So since 3 is less than 8, 3 1/3 is less than the square root of 15. Ordering real numbers. Express each number as a decimal, then order the decimals. Order the set of numbers from least to greatest. So let's first write them as decimals. So 8 4/5 is 8 8/10. The square root of 64 is 8. 8.3 repeating is already a decimal. And the square root of 76, use your calculator to calculate it, and it's about 8.71. So now we're going to order from least to greatest. So we can see that all our numbers start with an 8, so now we have to look in the tenths place. We can add a 0.0 to your square root of 64, so we can compare each of our numbers in the tenths place. So we have an 8, a 0, a 3, and a 7. So the smallest one is the square root of 64. Next, we have an 8, a 3, or a 7. Well, the 3 is smaller than the 8 and the 7, so it's 8.3 repeating. Now we compare the 8 and the 7, and since 7 is smaller than the 8, the square root of 76 comes third. Make sure you always go back and write the originals. So that means that 8 4/5 is the greatest. Number 4. Start by turning them into decimals. So we have the square root of 30, which is about 5.47. 5 6/10 is already written as a decimal. 15/3 is 5. And 5 2/3 is 5.63. So we can see that all our numbers in the ones place is a 5. So now let's look at our tenths place. We'll add a decimal point and a 0 to 5, and we compare. We have 4, 6, 0, and 0.6 repeating. So 5 is the smallest, so it's 15/3. Next we have a 4, a 6, or a 6, and that would be 4, so the square root of 30. Let's write the 5.6 and the 5.6 repeating off to the side. We can add zeros as placeholders, and we can see that they're different in the hundredths place. 0 is smaller than 6, so our 5.6 comes next, 5 6/10. So that means 5.2/3 is the greatest. Solving equations. By the definition of square root, if x squared equals y, then x is equal to the positive and negative square root of y. By the definition of cubed root, if x to the third power is equal to y, then x is equal to the cubed root of y. You can use these relationships to solve equations involving squares and cubes. Solve each equation round to the nearest tenth if necessary. So number 1 says a squared is equal to 49. So what we can do, take the square root of both sides. The square root of a squared is a, and the square root of 49 is 7. So we want to have both roots, because it's 7 times 7 is 49, and a negative 7 times a negative 7 is 49. So you must include the positive and negative root. Number 2, x cubed is equal to 125. So you want to cube both sides. The cubed root of x is x. The cubed root of 125 is 5. So our answer is x is equal to 5. D squared is equal to 38. Take the square root of both sides. The square root of d is d. And because 38 is not a perfect square, we're going to use our calculator, and it's going to be an estimate. So put the square root of 38 into your calculator. We get 6.16, but the directions say round to the nearest tenth, so we get 6.2. And we want to make sure we have the positive root and the negative root when we're finding the square root. Number 4 says a cubed equals 225. So we're going to cube both sides. The cubed root of a to the third is a, and the cubed root of 125 is not a perfect cube. So we're going to use our calculator. We're going to do 225 in the cubed root sign. We get 6.08. Round that to the nearest tenth, and it's approximately equal to 6.1. Here are some challenge problems. We have 5, 2x squared is equal to 32. Well, this is a one-step equation, so we can undo what's being multiplied first. So we have x squared is equal to 16. Take the square root of both sides. Get x is equal to the positive and negative root of 4. Number 6, 4x squared is equal to 100. First divide both sides by 4. We get x squared is equal to 25. Take the square root of both sides to get x is equal to 5. And you want to have both roots, positive and negative 5. Problem solving using square roots. So the aspect ratio of a hang glider allows it to glide through the air. The formula for aspect ratio is r is equal to s squared divided by a, where s is the wingspan and a is the area of the wing of a hang glider if its aspect ratio is 4.5 and the area of the wing is 50 square feet. Start by writing the formula. R is equal to s squared over a. We have our aspect ratio is 4.5, and we're also given the area, which is 50 square feet. So now substitute it in. It's 4.5 is equal to s squared over 50. This is a one-step equation. To get your variable by itself, we're going to multiply both sides by 50. So we're left with s squared on the right and 225 on the left. Take the square root of both sides. So on the right we get s, on the left we get 15, and that would be 15 feet. So the wingspan of that hang glider is 15 feet. A tsunami is caused by an earthquake on the ocean floor. The speed of a tsunami can be measured by the formula s squared over d is equal to 9.61, where s is the speed of the wave in meters per second and d is the depth of the ocean in meters where the earthquake occurs. What is the speed of a tsunami if the earthquake occurs at a depth of 632 meters? Round to the nearest tenth. So we're going to substitute in. The depth in meters is 632. So our formula is s squared over d is equal to 9.61. So our d is 632. So s squared over 632 is equal to 9.61. This is a one-step equation. We want to get the variable by itself. So we're going to multiply by 632 on both sides. So we end up getting s squared is equal to 6,073.52. We want to take the square root of both sides to get your s by itself, and we end up getting s, and it's approximately equal to it because we are going to round to the nearest tenth. We get 77.9 meters per second.